So I had you start by just trying to solve this one on your own. Many of you got it, but some of you still aren't sure. So let's actually take a look at the process we would use. To start, I'm bringing you back to the concept of order of operations. We were taking a look at this like last week and doing a lot with order of operations then. Well, order of operations still is useful when it comes to solving equations. It's just that when doing order of operations, we're just figuring out what something equals. So we do it in order, top to bottom. When we are solving an equation, we're undoing it. And so basically, when solving an equation, you are going backwards through the order of operations. So the first thing we do is we get rid of any addition or subtraction. Then we get rid of multiplication and division. Then the exponents, and then the parentheses from there. And so as I take a look back at this problem that you started off with, the way that we end up solving it then is we start by getting rid of any addition and subtraction. It's just that when we want to do that in this case, some people end up getting stuck on, well, which one do I need to do first? Because I got a couple of them. I got a plus here, I got a plus here. Which one should I get rid of? And the answer is that it doesn't actually matter. You can get rid of either of those first. Now, personally, my preference, and just kind of what I've made a habit just so I can kind of keep track of everything, is I always get rid of the x part first. And so in this case then, what that means is I'm going to want to move this 7x to the other side. So I'm going to subtract the 7x from both sides. Now you didn't have to do this first, but I tend to find it to be easiest. Notice I am writing under each side what I'm doing to both sides. And so then I end up with 3 plus 3x equals 15. Now, again, before I go too far here, why didn't I subtract the 10x? Yeah, that gave us a negative answer. Is that okay? Yeah. It's just that when we get the negatives in there, sometimes maybe it's a little bit more likely to lose track of the sign or something like that. So I tend to go with the one that keeps it positive. But it's not like a strict rule that you have to do there. You can work with the negatives along the way.
Some people prefer to have decimal.
Now, once I've made my first move in this particular problem, though, your next move is mandated by what you just did. Like in this case, since I already have the x on the left side, that means I have to have all the numbers on the other side, so I have to move this out of here. It's always just telling you based on what you did first. So I'm going to go ahead and subtract the 3 from both sides. And again, you notice I'm always showing what I'm doing, and then I do it. Show what you're doing to both sides, then do it. Over and over and over again. Got to see that work. And as I walked around, I was seeing that work for many of you, and it was looking really good. I was actually really pleased with the work I'm seeing. And so then this is our final answer. Now, you'll notice again, we talked about this when we first did some solving equation stuff. All the equal signs are vertically aligned. Not that I can draw a vertical line, but I'm lining up my equal signs to keep all my work as neat as I possibly can along the way. Now, for some of you, when it came to doing some of these assignments, and you're working on these, when it's, okay, how do I solve this? Sometimes the answer is, I go to Mathway, and I'm kind of okay with that, kind of not. And yes, some of you are like, yeah, that's me. And it depends on how you're using these tools. All right? Because these can actually be legitimate tools for you to use. You go to one of these sites, because there's all these sites on the internet that'll solve equations for you, do all this kind of work for you and all. But they claim to do the work for you, and they will show you all the work involved, at least if you create an account with them and give them personal information so they can then sell your data. Yes, they'll do some math for you. By the way, always think about what are they getting out of this, because they're not getting it for free. They're selling your data and your email address. If you're wondering why you get spam, things like this are often the cause. But even if you're using them, how can you use them? Well, if it does all that work for you, are you just copying down an answer and just copying it down? Or are you learning from it? when you see this kind of work that's just given to you, it can be either a tool that's actually used for learning, or it can just be a shortcut. When you use it as a learning tool, it can help prepare you. Now, by that, what I mean is that if you're feeling stuck on how to do a problem like this, and you go to one of those sites, and you have it give you all the work, if you then look at the work and are like, okay, what did they do? Why did they do that there? And if you're asking those questions, these tools are helpful. They're great. Because when you get stuck, they can help you see through some examples about how to do these. You may recall on like our first day of class, remember that really big process we did where we were finding equations of tangent lines? I just gave you a whole bunch of examples and you had to fill those in. I know, it was a month ago. That's like ancient history, right? But it was the same idea. It's how do you take examples of math that's already been done and actually use it? And it's for doing things like this. Yes, look at that work and use it to tell you why it works the way it does. But if you just use it as a shortcut, then you end up with a problem because shortcuts can get you points. So yeah, like you're doing an assignment, you can have it do the work for you and you can copy it down, you can type in the answer, whatever you actually need from the problem. And it'll save you probably about 20% of the time that you would have spent if you'd just done it yourself. It's not actually a big savings, but it's a little bit of savings. The problem is that when you do that, you aren't actually learning how to do it. And some of you are thinking, yeah, but I already know how to do it. Then you're not practicing it, which means you're not reinforcing it. I give practice on all these concepts because if we don't practice doing them correctly, we lose these skills. And as soon as we lose skills on, like, for instance, how to do something like this, then it means that we aren't able to do the stuff that we got on the horizon where we're going to be solving more complicated equations. Because we're building a foundation here that we're going to be building on later. Like solving square root equations and solving quadratics and solving absolute value, a lot of that kind of stuff. And so if you rely on this stuff just as a shortcut, yeah, it gets you points on that assignment, but that's all it gets you. It doesn't help you in the long run. Besides, the other thing is, if you use this on all your assignments, you'll get full points on the assignments, but then when you hit the test or quiz, you still don't know how to do it. And so you're not going to get the points on the tests or quizzes, and you cannot pass this class without doing well on tests and quizzes. Everything has to be there in order to be able to pass a class, including the assignments and the tests and quizzes. All right? So, yes, these tools are out there. Yes, use them. And no, I don't hate that you use them, as long as you use them correctly. All right? Now, taking a look at this exact problem, we saw the solution. If you just were looking at this, and just looking at this work, would it be enough to answer any questions that you had about it if we didn't explain it? That's then the question. So when you see problems and you don't know why we're doing what we're doing, make sure to be asking. All right, now, enough of the soapbox, right? Let's actually do some math. Please solve this equation, showing all the steps as we've seen. And remember, we're solving the equation, therefore we are undoing it. That's backwards through the order of operations. All right, so let's take a look at the work that you did in order to solve this. Remember, first thing I want to do is get rid of the addition and subtraction. That's the bottom of the order of operations. So in this case, that means getting rid of this minus 14 here, which means add 14 to both sides. So add 14, add 14. And so we got 20 equals 5x. 5x, remember, means 5 times x. Now if I'm going to undo multiplication, that means divide it. So I divide both sides by the 5. Yes, I do like using the division symbols with doing this, because if you just write that little line, sometimes you'll start finding yourself adding or subtracting instead of dividing, and you get yourself a little bit mixed up. So I do prefer the division symbol. All right, so 20 divided by 5 gives me 4 on the left side, x on the right side. Is it okay for the x to be on the right side? Yeah. Yep, we can go ahead and stop there. You do not need to force the x onto the left side. This particular problem could potentially lead you into a trap if you're not really careful. Because if you just looked at the last problem and said, okay, I'm just going to do the same thing. I'm going to get rid of the addition and subtraction on the end. If you did that and subtracted 10 from both sides, well, all you'd have then is 9x minus 10 equals 7x. And then your next step, logically, probably after that, is I'm now going to add 10 to both sides, and then you're going to end up with 9x equals 7x plus 10. You're just going to be going around in circles, right? So that's why, yes, we are going to get rid of the addition and subtraction, but we're still doing so with the original intent of solving an equation in mind. The main idea of solving an equation is getting all of the x's on one side and all the numbers on the other. And in this case, I already have the number part by itself. So I'm going to leave that 10 on the right side. I'm just going to move instead the 7x out of that side. The question is, how do I get it out of there? We got to subtract it, yes. Because that 7x is positive. That's why we subtract the 7x. Because basically what we're doing is we are actually doing this 7x minus 7x. Which gives me 0x, which is just 0, which is why I don't need to write it in, because it's just 0. And so we have 2x equals 10, then we just divide both sides by 2, easy from there, right? So we get x equals 5 for our final answer. So in this case, again, we're now back to having x's on both sides and numbers on both sides. I do tend to make a habit of getting all the x's together first. It's not like you have to do it that way, but it's a nice habit to be in. It can help. That means that I'm going to move either the 3x or the 2x from its side. It doesn't matter which one you do, but I do tend to like my answer to be positive. And so that tells me to subtract the 2x from both sides, because I'm kind of thinking ahead. Now, if you aren't seeing that right away, then just go with one. Because you might not see right away what the answer will be after you do it, and you could just run with one of them and see where it takes you. As long as you're following the rules, you'll still get to the right answer. All right, so when I do the 3x minus 2x, that gives me 1x. Remember, I don't have to write 1x, I can just write that as x. Makes your life a little bit easier here too. All right, and then finally, once we have it written like this, we know what to do. We got to add the 7 to both sides, so we end up with x equals 12 for our final answer. All right, now for this problem, I want to show you something which kind of works and kind of doesn't. And it's worth mentioning and it's worth discussing. A lot of people will look at this and say, okay, first thing I want to do is I'm going to go ahead and move the 3x. Okay, one doesn't write right away. And at the same time, I already know what I'm doing, so I'm going to go ahead and move the 9 at the same time, or move those numbers together. Okay, so then that means I'm going to go ahead and add... Let's add that 4 to both sides, and I'll see this work on people's papers, and then they'll do that work, and they'll end up getting 5x equals -5, like that. However, there's a problem with this. Can you see what the problem is? All right, so you're right there. Everything on this line is something we can do. But if we did that, notice the -3x and the plus the 4, that would actually not give us this. If we actually did that correctly, because technically we can do that, it would actually give everything on the right side. So what would be left on the left? Just a 0. I mean, technically we can do that, and you'll actually, if you continued from that line, you actually could still solve it out correctly. But this is a great example about why I'm always saying do one step at a time, because the person here tried to do 2 steps at once and ended up causing a bunch of problems. All right, and then it didn't want to erase the rest, so I'll just cross out the stuff it wouldn't erase. What we should then do is, yes, we can go ahead and subtract the 3x from both sides, so subtract 3x, subtract 3x. And so then I have -4 equals 5x minus 9. Then we can see that we have to move the 9 to the other side in order to keep it together. And you guys saw that, yes, I need to move the 9 instead, but being able to see why is part of the trick of that. And then we divide both sides by the 5. I'm running out of room, so I'm going to squeeze it on the page there. And so then we end up with 1 equals x. which yes, is our correct answer and what we're looking for. But notice, one step at a time helps prevent us from making some little mistakes along the way. All right, so for this problem, we do end up seeing something kind of unusual happen. Let's take a look at the work and see what would end up being the case. Now, if I follow my same tendencies here, I'm going to start by moving all the x's to the same side, and I like to keep them positive, so I'm going to subtract 6x from both sides. When we do that then, we have 7x plus 11 equals 11. And from this step, I have to now subtract this 11 from this side in order to get rid of it. So we're going to subtract 11 from both sides, which gives me 7x equals 11 minus 11 is 0. That's okay. A lot of times what happens at this point is we see 7x equals 0 and we assume we did something wrong. But we didn't. It's okay for it to equal 0. I just keep following the same rules I know to do. So still, if I want x by itself, I divide both sides by 7. That's the only way I'm going to get the x equals. And so x equals, what is 0 divided by 7? 0. And so x equals 0. So yes, that's okay to have happen.